Good morning all. Today we will discuss about the Phasor diagram of RLC circuit. Phasor diagram. So, good morning all. Today we will discuss about the Phasor diagram for RLC circuit. So, we will study the RLC circuit to discuss about its Phasor diagrams. So, before going to discuss about the Phasor diagram of RLC circuit, let us discuss the basics of Phasor diagram. So if we want to understand the Phasor diagram of RLC circuit, we should know what is a Phasor diagram. So what is a Phasor diagram? So Phasor diagram is the diagram representing phasors. That means it is the graphical representation of phasors. Now we should know what are the phasors. Then our knowledge will be complete about Phasor diagram. So we understood Phasor diagram is the diagram representing the phasors. So we should know what are the phasors. So phasors in the electrical engineering, because we are discussing about the topics in the domain of electrical engineering. So in electrical engineering are the lines or arrows which are used to presents or represents the magnitude the better to say peak amplitude of the AC parameters. Such as V, I, etc. Along with their direction, and that direction will define, that is defining the phase angle with respect to a predefined reference. Therefore, we can take an example. Say if we have the reference axis here, and if we want to represent the peak amplitude of any electrical quantity, say A may be V, I or similar, and with the reference axis it will have a particular angular displacement. That angular displacement may be varying from 0 to 360 degree, and in any direction, either clockwise direction or anti-clockwise direction. So we can call this representation with the help of this arrow and angle theta. Say we can take any other angle also, phi or anything else. So this A is nothing but a phasor. So A is a phasor. And by the convention, if the phasor is represented along with any other phasor, say B, and having another angle, say it is called phi, we can define it with any other angle also. So we can tell that the phasor B has an phase angle with the reference frame as phi, but between the A and B the phase difference will be phi minus theta. So in this way we can represent main layers and their position, etc. So phase is not representation of the quantity, represent quantities along with the time frame. That means their phase or phase angle. Now, if we think there are two electrical quantities, say voltage and current. So V stand for voltage, say V is generally used for representing the voltage and I is used to represent the current through any circuit. And if V and I are associated with the same circuit, that we can assume that I is produced due to the reason V, and if we see that I is found along the reference axis, then we will call that I has zero phase, because there is no phase displacement between the reference axis and the I. And if we find that the phasor V has an angle, say theta, and if we are getting the location of V after moving towards the anti-clockwise direction, means this direction, then we will call this V as a leading phasor, and this angle will be the phase angle between them, and V will be called as V is leading over I by an angle or phase angle theta, or in other words we can tell I is lagging behind the V by an angle theta. So this is by convention, and if we get any other vector or phase vector which are also found after moving towards the clockwise direction also, so in that case, say this is V2, we can discuss or we can assume that. So V2 will be lagging behind I, and I will be also called as leading over V2. So like that we can get the idea of leading phase and lagging phase.